Hello everyone, Suhail this side. Welcome back to my channel and Kafka series. In this video, we will look at Kafka partition assignment and rebalancing, but in a very practical way. We will see this via coding by starting and stopping multiple consumer instances within the same consumer group and observe how partitions are reassigned in real time. We will also discuss different rebalancing strategies and why choosing the wrong one can impact every consumer in a production application. This is one of those Kafka topics that looks simple on paper but causes real outages if misunderstood. So stay tuned, we'll walk through this step by step via coding and it will be fun to watch. I would recommend watching this video till the end to see the complete picture. So without wasting time, let's get started. So for Kafka partition reassignment or rebalancing to happen, what are the prerequisites? The prerequisite is we should have topic with more than one partition. Now in this case, we have topic with three partitions. Let's say this is partition 0, this is partition 1 and this is partition 2. And let's say the topic name is order events. Let's keep the same topic name which we were using in the last videos, right? And this is the publisher which is continuously publishing the messages onto this topic. In ideal case, in happy case, right, if we have three consumers, so what Kafka would try to do, Kafka would assign each partition to each consumer, right? But if we don't have three consumers, right, in that case what would happen? So Kafka would assign all the three partitions to this consumer if we don't have any other consumer. If we have a single consumer, Kafka would assign all the three partitions to a single consumer, right? But as and when the consumers keep coming up, let's say in initial phase this was the only consumer up, right? So Kafka assigned all these three partitions to this consumer, right? Now for scalability, what you do, you spin up another consumer, right? So in that case, what would happen? So Kafka would, let's say, remove this partition, right, and assign this partition to this consumer. So it is a kind of reassignment of the partitions. So partitions are rebalanced and the partitions are assigned to new consumer, right, in this case. So when this consumer is coming up, again what Kafka would do, again Kafka would do the Kafka partitioning or Kafka partition rebalancing or reassignment. So in this case, what it would do is it would remove this partition and it would assign this partition to this consumer, right? So this is the way the Kafka doing partition rebalancing or reassignment. There are different strategies for reassigning the partitions to this consumers. It could be like this also. For example, instead of this, what it would do is it would assign this partition again to this and this partition again to this, right? So there are different strategies for assigning the partitions to the consumer. We will discuss all those strategies as well. Let's go to the IntelliJ and see the demo, how we can see real partition rebalancing happening in our code, right? So this is the IntelliJ project where we were coding the producer and the consumer for our Kafka series. So for this case, what I will do is, first of all, I would create a package called as day3, right? So that you can see what all new changes I am making in this class, right? So I'll just create the day03 package, and what I'll try to do is I'll just copy these classes into day3 package and I'll just rename those files. So now I have created Kafka consumer and Kafka producer. These are the similar files which we have already coded in the last videos, right? Now what is our requirement? Our requirement is to spin up multiple consumers to see the partition rebalancing or reassignment, right? So how we can do that? So for this, let's go to the consumer class, and so this is one consumer, right? So this is one consumer which we are spinning up at this moment, but we need similar three consumers to be spin up, right? So for this, what I'll do is I will just rename this method to, let's say, the start, and I can just pass the, in this method also I can just pass the instance ID, right? Why I'm passing the instance ID is because every consumer would be having their own instance ID. So we can use the instance ID here, right? So I've already discussed all these concepts in the earlier videos, so please follow the last videos where we have discussed in detail what is this configuration, why it is being used, right? So I have discussed everything in detail. So for simplicity, what I can do here is I can just use the try catch block here, right? So that, because what happens is when we see the demo for Kafka partition assignment or rebalancing, it throws the exception, right? But in this case we are not catching any exception, so our while loop would break. So that's the reason I'm just catching the exception over here, right? I can just log the message, right? So that so that we can see that something has happened while the partition reassignment or rebalancing is happening. Now our code is done, right? So we have the start method. Now what I'll do is I will create one more class, right? So day 03, or let's day 03, and let me create the Kafka consumer group, right? So we'll use the Kafka consumer group, and in this class what I will do is I will try to spin up multiple consumer instances. So for this, what I'll do is static class, let's say the consumer 1, right? And in this class what I will do is I will just define the public static void main method. So in this case what I'll do is I will just create the day 03 Kafka consumer, and I will just pass the instance ID as 1. Let's say this is the instance ID for consumer 1, right? And we have given the name of the classes such that, right? So if you see now, it would spin up one consumer instance when we call this main method. So similar to this, what we can do is I can create the more classes for this, the consumer 2, right? And here I can pass the ID as 2, and again what I will do is I will just again create the consumer 3, and here I can pass the ID as 3. Now our 3 consumers are there. So before starting the consumers, what I need topic with more than one partition, right? So let's go to that and let's create the topic with 3 partitions. So for that I'm just opening the console. So what I'll do is I'll just see whether my Docker container is running or not. So the people who are new can refer to the Kafka Docker setup on to my channel. I have published a detailed video on this. So let's go to this container, right? And let's go to this. So once we get into this, we do cd Kafka bin, right? And let's see the Kafka topics, what all topics are there, right? So the command, you should be knowing this because we are using like in every class, right? And what I'll do is I'll just see the topics, what all topics are there. Sorry, I'm just using the different bootstrap server. It's not servers, it is server, right? So bootstrap server localhost 9092, that's where our Kafka container is running, and we are just trying to list out all the topics, what all topics are there. So there is nothing, right? So I'm just clearing the console at this moment, right? So what I'll do is I'll just create the topic. So for that, what I need to do is I just need to create the topic. So I can just do the order events and I can do create, but we need topic with 3 partitions. That's the key point. So for that we need to specify the partitions like this. So just enter that and our Kafka topic is created. Now if you want to see the real how many partitions are there, so for that what you can do is you can just do the describe command, right? We have already discussed all those things, but just for rewinding I'm just seeing that, right? So now we have the 3 partitions, partition 0, 1 and 2, which I have already shown in the diagram, right? Now we have topic with 3 partitions. What I can do now is I can just start the consumer 1. Let's start this main method, right? And let's see what happens. Let me resize this. So if you scroll up, you would see the partition assignment, right? So you would see So if you see over here, the partitions have been assigned. Order events 0, so 0 partition, 1 partition, and the second partition. So all the 3 partitions are assigned to which consumer? Only the consumer 1. But this consumer refers to which consumer group? So if you see over here, right, so it is the inventory service consumer group, right? So we have consumer and all the 3 partitions are being assigned to this. Now what I will do is I will just start the producer as well. So what I will do is day 03 Kafka producer. So instead of 100, what I can do is I can publish 10,000, right? Because we want to see the demo in partition reassignment or rebalancing, right? For that we need some time so that we can see the consumers are being assigned partitions, right? So for that what we need is we need the continuous data gets published to the consumer, right? So that then only we'll see the real behavior, how the partitions are being assigned to the consumer while Kafka server is up and running. So what I'll do is I will just start the producer now, right? So we already have everything here. So I will just start the producer. What is producer is doing? The producer starts publishing messages, and if you see, the consumer starts consuming the messages. So this is my consumer 1. What I will do is, so if you see in as of now how the partition assignment has happened, so every partition 0, 1 and 2, all 3 partitions have been assigned to this consumer. Now let's see when we spin up this consumer how the partitions are reassigned. So let's start this consumer and see the behavior, right? So if you spin up this consumer, so if you see, so the consumer 2 has been assigned the partition 2, right? So if you see the order events 2, this is the partition 2, right? So this partition has been assigned to consumer 2. So in next iteration, what has happened? And if you go to the consumer 1 logs, let me scroll down, and if in the logs you would see the partition rebalancing message. So if you see over here, right? So if you see over here, what has happened? So it has revoked all the previously assigned partitions from this consumer. It has revoked all the partitions 0, 1 and 2, right? And reassigned the partition 0 and 1, right? To consumer 1, which we have started earlier, right? So in the next iteration, what has happened? So next iteration, let me write down here, 0 and 1 has been assigned to this and 2 has been assigned to this, right? So at this moment, 0 and 1 partition has been assigned to consumer 1 and 2 partition has been assigned to consumer 2. Now let's spin up the consumer 3 and let's see the behavior. Let's see how it is behaving. Now if you see the logs, right? So the partition 2, right? So the partition 2 has been assigned to consumer 3. So this is the consumer 3. This partition 2 has been again assigned to consumer 3. But in last, when we spin up the consumer 2, the same partition has been assigned to consumer 2. So what has been the behavior for consumer 2 at this moment? So let's see the consumer 2 logs again, right? So this was the earlier case when the partition number 2 has been assigned to this consumer. It was processing the messages happily, but suddenly any new consumer spins up, right? Now let's see the logs. So if you see the logs, what has happened to this consumer? So this consumer has also revoked all the partitions. So it has the partition 2 has been revoked, right, from this consumer, and what has been assigned to this? The partition 1 has been assigned to this. So this is revoked, right, and partition 1 is assigned. And in this again it has revoked 0 and 1 and only assigned 0 partition, right? So let me write this: 0, 1 revoked and 0 is assigned, right? So this is the case right now. So if you see the behavior of this, so whenever we are spinning up any consumer, right, so each and every consumer is affected, right? So we have seen that because when we spin up the consumer 3, the consumer 2 has also been affected, right? Ideally it should not be because it was assigned only the single partition, right? And it was happily processing the messages. But the rebalancing happened for this consumer as well, and the partition which was earlier assigned to this consumer now assigned to this consumer, the consumer 3, right? So these are the kind of performance bottlenecks you would see in production application if you don't do the Kafka tuning right, if you don't use the partition strategies rightly in the production, right? So what we can do in this case, right? Let me stop this at this moment. So what I'll do is I will just stop everything. So I'm just removing each and everything from this so that we can start from fresh. To fix this behavior, what we can do is, if you go to the consumer, right, and there is a property, right? So what property is there? Let's see, props dot put, and not the max poll records, right? Not that, it is the assigner, yeah, partition assignment strategy config, right? So if you see this, in this case we can assign the cooperative sticky assigner dot class dot get name. So this is the kind of assignment strategy, one of the assignment strategy we can assign to this consumer group, right? So if you can implement your own partition assignment strategy because it provides an interface, right? So if you see, it provides an consumer partition assigner is a interface. You can customize your logic according to your needs, but I believe this is the one which is best suited. So I'll just close all the things and let's see the behavior right away, right? Again, what I'll do is I will again to the consumer group, right? What I will do is I'll again spin up the consumer 1, right? Let's spin up that, and if you see, the consumer has been assigned. If you see the logging, first of all, right? So the logging is a bit different, right? Initially when we start the consumer 1, what has happened is all the three partitions have been assigned to this consumer. So what we'll do is we'll start the producer now so that we can see the messages getting processed. So let's start this producer, right? So if you start the producer, right, the producer is producing the messages, the consumer starts consuming the messages and starts processing the messages, right? Now let's see closely how the assignment is working right now, right? So right now all the three partitions have been assigned to this. Again, I am writing everything here, 0, 1, 2, everything is being assigned to this. Now let's see what happens to this consumer if we start up this, right? So let's start this, and if you see the logs, right? So if you see the logs, what partition has been assigned to this? The partition 2 has been assigned to this, right? And it start processing the messages, right? Remember, there is no message loss, right? Because we are committing the offset only and only when the message gets processed successfully, right? So remember that thing. Now it is processing the messages and the partition 2 has been assigned to this consumer 2. Now let's start the consumer 3 and start seeing the behavior, what happens, right? So if you start this consumer, right, and let's see the real behavior, how it happens is, right? So what would happen, just wait for a second. Yeah, if you see the logs, right, now this consumer, the consumer 3 has been assigned the partition 1, right? The consumer 2 is not touched. It was happily processing the messages because the partition 2 has already been assigned to this consumer and it is happily being processing the messages. This consumer 2 is not being touched, right? And only the consumer which is being touched, which the consumer has more partitions, right? So in this case, this consumer was having partition 0 and 1. Only this consumer has been affected and the consumer 3 has been affected, but the consumer 2 is not touched, right? So with this we get the great performance benefits as and when if we are running any system at scale. So let's stop this everything. Now let's proceed further. So this part we already discussed, right? The partition rebalancing strategies. So by default, what happens is this is the partition strategy, which is the by default. So if you see, as we already seen the demo, right? So the partition 0 is the yellow color, 1 is the green color, and 2 partition is the pink color. So initially what has happened is all the 3 partitions have been assigned to this single consumer. So as and when we spin up this consumer, right, the consumer 2, so pink color partition has been assigned to this consumer, and the remaining of the partitions had been already been assigned to consumer 1, and the partition reassignment has happened, right? And these of the 2 partitions has been assigned to this, and this partition has been assigned to consumer 2. And when we spin up the third consumer, right, so with default strategy, what happens is, so earlier the partition 2 was assigned to this consumer, right? But now with this default strategy, what has happened, this also rebalanced, right? So all the 3 partitions, all the 3 consumers are rebalanced, right? So what has happened in the final stage is, again, this partition 0 is assigned to this is assigned to this is assigned to this. So by default, how the flow happens here in this case is, so it sorts all the partitions in sorting order, right? And also the consumers also sorted by the instance ID. So if you see, the instance ID for consumer 1 is 1, the instance ID for consumer 2 is 2, and the instance for consumer 3 is 3. So when we sort these consumers, so in the sorting order, this would be the place, this would be 0 index, this would be first, and this would be second. And when we sort the partitions as well, this would be the default order. So according to the sorting, this rebalancing has happened. So this is the default strategy. Now what strategy we have chosen, that called as cooperative sticky assign strategy. So it's a kind of sticky session kind of thing, right? So this we have already seen. But when this has happened, the new consumer comes up. So the partition 2 has been assigned to this consumer, right? So it is kind of stick to this consumer, right? It is not touched when the new consumer comes up, because which is the consumer who is having more partition, the consumer 1 was having the more partitions. So in next phase, any of the consumer is coming up, so only these partitions are being reassigned. This partition is not touched at all. So that is the cooperative sticky assigner partition strategy. Now let's see the callbacks. If we want to do any operation on partition assigned or on partition revoked, there are some callbacks which we can implement in our code base. Now let's see how we can do that. But before moving to the demo, we need to discuss few of the things that is very, very important. So we need to understand when actually partition rebalancing happens. So it is not Kafka broker that notifies all the consumers, right? So it is not Kafka broker who notifies all the consumers that, okay, I have reassigned the partition to this consumers. No, what happens is, whenever the consumer calls the poll method, right? Since Kafka is based on pool based approach. So when consumer calls this poll method, what happens is the call goes to the Kafka broker, right? So at this moment, the broker would see what is the condition for the partitions. Is this consumer new or is this consumer old? Based on that, it would reassign or rebalance the partitions. So on poll method, the partitions are being reassigned and rebalanced. This is very important point to note. Now let's see what kind of operations we want to do in partition callbacks. So as and when the consumer is coming up, right? As and when the consumer is coming up, right? So in this case, our requirement could be whenever the partitions are being assigned to this consumer, we might want to move the offset by, let's say, the last 2 messages or last 10 messages, right? So for example, let me erase all this first, right? So that I can explain you better, right? So let me erase. Now what happens is, if we have some kind of Kafka broker, right, and we have topic, right, which has the aggregated information, let's say the number of orders processed, right? Let's say this is the kind of number of orders processed. There are some kind of aggregated data gets published onto this topic, right? So the consumer, whenever it is coming up, right, it doesn't have any storage. Whenever the consumer is coming up, it might need to get the last message, right, to get the pre-populated value for this order processed. So whenever the partitions are being assigned, you might want to seek the offset to a particular position, right? Whenever the partition has been assigned, you might want to read the old message. So for example, as we discussed, right, so this is the current offset and this is the log end offset, right? So you might want to, this is the current offset at this moment, right? You might want to see the last message. So what you would do, you would just move this offset to this position so that you can just get this message, right, and pre-populate the cache. This is the kind of requirement when you might need to get the aggregated information, right? So in these cases, what you can do is, on partitions assigned, you can do this. You can get the last message, you can seek the offset to a particular position. And on partitions revoked, right, whenever the partitions are being revoked, so in that case what you can do is you can commit the offsets for those messages which are already processed, right? So let's see how we can do that in coding. So this is the consumer class which has everything, right? Now what we need to do is we need to assign the callbacks so that the Kafka library can call those callbacks whenever the partitions are assigned or revoked. So for this, what is being done? So in this subscribe, it has give us the consumer rebalance listener, right? So this is the kind of interface it provides, and it provides the method like on partitions assigned or on partitions revoked. So in this case, we can just log this method, for example, logs.info partitions revoked. But in partitions assigned, as I earlier discussed, usually on partitions revoked, what we do is we just commit the offsets for the messages already processed. So this is the usual thing which we do whenever the partitions are being revoked, right? And on partitions assigned, what we do is we can just, for example, we have this, and we can do the for, and we have this, so we can iterate on this topic partitions. So what we can do is we have the consumer dot get or consumer dot position, and we can just pass the topic partition. So what it would give us, it would give us the current position, right? So it would give us the current position. Now in the next step, what we would do is we would need to move the offset. So what we'll do is long seek to, right? So what we'll do is long seek to is current position minus 1. Let's say this is the current position as I already discussed, right? Now if we want to seek the offset to a particular position, we can just do this, but just to be sure, this number should not be negative, right? This number should not be negative. So for simplicity, for safer side, what we can do is max.math, and we can just apply that the 0 or the current position minus 1. So every time whenever the partitions are being assigned to this consumer, we are just moving the offset to one message earlier. So that is the kind of thing we can do in this partition assignment, right? So I can just show you the demo quickly, right? So for that, again, I need to start the consumer, and I started the consumer. I started the producer. Let me start the producer. I have started the producer. The consumer is consuming the messages, processing the messages. Again, I will start the consumer 2, right? And let's start the consumer 2, right? And see the behavior. Again, it would do the same thing, right? It is processing the messages. So our job is done. So what we want to do is whenever the partitions are assigned, we want to see whether this offset has been seeked to a particular position or not. So let me just see the logs. I can just show you, right? Let me see what is the log we have printed. Okay, sorry, we have not printed any log. So for seeking to offset. Let's say this is the kind of log we want to print, right? So sorry about that, I have not printed the log. So what I'll do is I will just start the consumer one, right? And I will just start the consumer one, and again I will start the producer just to show you the demo, right? And if you see the consumer one, right, so it has been moved to offset 1551, right? So it has been assigned the offset because we have the topic with 3 partitions, so every partition has a different offset. So what we are doing is we are moving the offset for every topic partition, right? So if you see the code here, so we have done the for loop, so it should be running 3 times. So seeking to offset 1, seeking to offset 2, and there should be one more seeking to offset 1614. So when all the 3 partitions have been assigned to this, it is one by one seeking the offset. So if you see at one time, when the partition has been which partition has been this, so let me just see. So when partition 2 and partition 0 and 1 has been assigned to this consumer, it has moved the offset for these 2 topic partitions. And later when the partition 2 has also been assigned to this, what it has done is it has moved the offset for this topic partition as well, right? So this is the newly added partition, right? So it has moved the offset for this partition. So this kind of operations you can do in this callbacks. So let me stop all this. So we have already seen this, right? So this is the callbacks, the on partition revoked and on partition assigned, and how we are passing this as a listener to this, the consumer. So in the subscribe method, we are just passing this consumer rebalance listener, right? So this is the interface. We have to implement in this interface and provide the implementation into this subscribe method. So that's all I had planned for this video. Today we saw Kafka partition assignment and rebalancing in action by starting and stopping consumer instances and observing how Kafka reacts. We also discussed rebalancing strategies and why choosing the wrong one can impact every consumer in a production system. In the upcoming videos, I will go much deeper with fault tolerance demos, optimization techniques, and real-world Kafka scenarios. If this video helped you, please do like and share it with your teammates or friends. It really helps the channel. Thanks a lot. Thanks for watching. See you in the next video soon.